Do you want to do this? Hello, and welcome. If you are here, I imagine you are interested in this. This is a circuit-bent VGA signal generator that produced the images in the intro there. It's based off of a very simple schematic designed by a man named Jonas Bers. He calls it the CHAV. I presume that means cheap AV, according to his little blog post about it, which is very informative, has a lot of information on it. I will link that down in the description. But basically, all we're working with here is the signal generator, which is cheap on Amazon. Basically, it just outputs test signals for testing LCD monitors, any VGA device. A few pots, 10K pots, or whatever you want to use. Some caps, and this little chip right here, which is also very cheap, and that is the CD40106. It's a series of Schmidt trigger inverters, and even though this data sheet is very long and extensive, it's actually an extremely simple thing to put together. You'll see here there's only really 2 wires per oscillator. That's what we're using it for, is to oscillate and to modify the video signal. There's a red, green, and blue wire, and then a horizontal sync and a vertical sync, which you don't even have to use. Then there's power, which you can just piggyback right off of the PCB here. It's a center positive power supply here. And if you don't know what that means, I'll also put some information about that down in the description. So let's take a look at what we need to make this work, and we'll get to building one. A VGA signal generator. I bought mine in a 2-piece lot for $8.99 from Amazon. There's a bunch that are basically the same design if you just search for VGA signal generator. Just make sure you are certain how much power it will actually require in order to run. Breadboards and jumpers. Or a breadboard if you want to jam it all into one and save some money. But you will need wire of some sort, and if you're using a breadboard, I'd suggest having as many male-to-male jumpers around as you can at all times. A power supply of some sort. This particular signal generator can operate on anywhere from 7 to 12 volts, and since you can just run some wires from the jack on the board into your breadboard, you can power everything from the same supply. I am using a cheap universal Walmart wall wart with different voltage settings and have it set to 12 volts, which is within the range of acceptable voltage for the chip and the generator. Just be sure that if you are using something other than the IC in this project, you don't give it too much power. An IC capable of oscillating. In this project, we're using the IC suggested in the original project by Jonas Bers, the CD40106. However, there are many other options, including even simpler designs like Look Mum No Computer's Super Simple Oscillator, which uses a single transistor, a capacitor, a few resistors, and a pot. I will link to his design in the description. Wire. For anything requiring soldering, you will need wire to connect things. I use 22 AWG solid core wire, which also works in most breadboards, but there are heaps of options out there, and you can even salvage wire from things like old network cables if you have some lying around and you don't want to spend money. For each color in the signal, you will need a 0.1 microfarad electrolytic capacitor, a 0.1 microfarad ceramic capacitor, and a potentiometer to modify the frequency of your oscillator on the fly. The original design calls for a 10K or 100K pot. I'm using 10K. You will need an oscillator per color, and the IC I've chosen for this build is capable of producing 6 oscillators total. So if you want to control all 3 color channels at once, you will need to have 3 times the caps and pots. But you can get away with only messing around with a color at a time if you're on an extreme budget or trying to keep it as simple as possible. And finally, you will need soldering iron and solder. There is a broad spectrum of choices when it comes to soldering irons, and for extremely simple soldering, as will be necessary in this project, the cheapest you can find with decent reviews will be perfectly usable. I use a very reasonably priced soldering station with adjustable temperature, which I will link, but if you don't have plans to do much soldering outside of this project, I'd say that kind of an investment is overkill. As far as solder, I'd suggest leaded solder as it's the easiest to work with, and if you use a soldering iron with non-adjustable temperature, it may or may not get hot enough to easily work with non-leaded solder. Here's a few completely optional things that you can consider. You can implement a sort of low-budget sync if you have a single-pole double-throw switch, and I have implemented this in the design I'm throwing together. But the switch itself isn't necessary to making cool stuff happen with this project. I will demonstrate its effect, and you can decide. And a speaker if you want to hear the sounds your oscillators are making. The entire bill of materials will be listed in the description, as well as links to purchase any of the items. Now let's take a look at the soldering we will be doing. So here it is. You've got your power here, and it's got 2 buttons. One is for changing the resolution, the other is for changing the image or the test pattern that it's sending out through the VGA into your display. On the back here, we've only got a couple things that we're concerned with personally, and that is we've got your power here, which we will solder into cables, and then you've got 3 pins here. It's your red, green, and blue, and then over here 2 more pins, your vertical sync and horizontal sync. If you are not going to implement sync into this design, then you don't have to worry about those at all. And for the purposes of breadboarding, what I like to do, especially for things like power, is take your regular breadboard jumper cable such as this, clip one end of it off, and expose the wire, solder that part to your power or to whatever, and then on the other end you've got a jumper that will just plug straight into a breadboard. It makes it nice and modular and easy. Obviously, if you go to put this into a box or design your own, circuit for it, you will have to just solder wire straight to it and from point to point, or however you go ahead and design it. But for the purposes of breadboarding, chopping these cables up actually makes that really simple. So that's what I will be doing. So let's go ahead and solder. Alright, so I'm going to be honest with y'all. I forgot to turn the mic on when I was shooting myself soldering all these wires. So if you just follow the image that'll be in the description showing which one of these goes where, in case I wasn't clear enough about that earlier, you should be able to do this no problem. I mean, it's a total of 7 wires. Just make sure that you connect the positive and ground of the power correctly. when you're doing that. So now that the wires are all soldered, let's go ahead and put this stuff in our breadboard here. You can see I've already put the IC in, and it takes power on pin 14, ground on pin 7. This is a really common arrangement for ICs of this type. Just make sure that you check the data sheet on each one. And then I've got 3 10K pots here. And we'll start off with a single color channel. And I know that a lot of people, when they are demonstrating breadboard setups and builds, will cut wires to length and make everything really nice and neat. I don't really have the patience for that, unfortunately, but it's such a simple design that it shouldn't get cluttered and you should be able to follow along. If you have any problems, just, leave a comment. I will help you as much as I can. But for a single channel, it's only a couple wires, so if we're following the schematic here, which may or may not be in focus, I'm not sure, I can't tell. This just shows pins 1 and 2 on this IC here. This is an input, this is an output. Pin 1 is connected to the wiper, which is the middle pin or leg on this pot. And is also connected, if you're going to implement sync, this will be run into a switch. If not, pin 1, the positive side of an electrolytic, a 0.1 microfarad electrolytic capacitor, will go towards pin 1, and the negative will go towards ground. In this case, we are going to use a switch for vertical and horizontal sync. So this will actually go from pin 1 into a 0.1 microfarad electrolytic capacitor. On the positive side, the negative side will go into the center pin of this switch. Then on either side, you'll have one running into ground and one running into your vertical sync and horizontal sync. It has the same effect in the right position of tying pin 1 to ground. That's all this will do in a passive state, basically. So first we want to connect power and ground, and then we want to make sure to also connect that to here so our chip can be grounded. And also we're going to run these into ground. So if we follow the schematic, pin 1 runs into the wiper of a pot. Pin 2 runs into one of the legs or pins on the pot. And even though this isn't in the schematic, I always also ground the other leg or pin on a pot, so we're going to go ahead and do that. Now the only things that are left are, since we're using this switch, we will tie pin 1 to the center pin of this switch with the 0.1 microfarad electrolytic capacitor. So the positive side goes towards pin 1, the negative side goes towards the center pin of this switch. And also following the schematic, that means one side of this switch will be run into ground. And the other side, just connect this over here, will be run into sync. Now, I'm not sure how Mr. Jonas Bers had this designed specifically in mind. I've been connecting both wires from vertical and horizontal sync into the switch. So, you know, it activates both of them whenever you have the switch activated. Then we take our 0.1 microfarad coupling capacitor from pin 2, and this is non-polarized, so it doesn't matter which way you put it in, and run this to somewhere else on the breadboard, and then that's what we connect our color channel with. And it's already a mess, I understand, but it's very simple, so I'm hoping you're able to follow along with this. And aside from plugging this in and connecting it to a monitor, that should be all we have to do. So let's take a look and see if it works. So we should have some type of output here now. Test and run through the different image modes here. Until we get to the blank. This is what we're looking for right here. So let's just test. Okay, seems to be working. Now, you can see cheap hold. It works. Let's unplug this. And then we'll go ahead and do the same thing for the rest of the colors here. Okay, well, that should be it, so let's plug it back in and have a look. Seems to be working just fine. Alright, so that's pretty much it. The thing to remember is that all of these capacitors, you can change their values, and it affects how the video looks. It will change your output and modify it. I think that He said higher value caps will produce more horizontal lines, and lower values will produce like vertical lines. So that's something to play around with. You can literally just jam anything in there that you want cap wise and see what happens. So this has pretty much been it. Let's go ahead and take a look at some video of stuff this can do. And I thank you for watching. I hope you learned something, and if you have any comments, go ahead and leave them down in the comments. I will definitely respond. Also, I'd like to apologize for the quality of my microphone. It sucks. I'm sorry for my voice also. There's nothing wrong with it. That's just the way that it sounds. So, I hope you enjoyed this, and thanks for watching. See ya.